Assalamu alaikum wa rahmatullah. My dear students, this is Dr. Shubair Abdullah. I welcome you into this lesson that will be devoted to IPv6 dynamic routing. This lesson is the second part of IPv6 routing. In the first part, we covered the static routing. On this lesson, we are going to cover only the dynamic routing protocols in IPv6. We will introduce the dynamic routing, then we are going to know what is the interior gateway protocol and exterior gateway protocol, and also the border gateway protocols available for IPv6. Then we will focus only IPv6 interior gateway protocols, and we will explain the three common dynamic routing protocols for IPv6, which are RIP-NG for IPv6 and EIGRP for IPv6, and the OSPF v3, which is for IPv6. Okay, for the topology that we are going to use in configuration, because after this lecture we will do some practice to configure these three protocols. So we need a topology to do this practice, and we will use the same topology that we used in our previous lessons, specifically in the IPv6 configuration lesson and in the static IPv6 routing lesson. So if you want to know details about this topology, you can go back to this lesson and you will find a full explanation of the topology. We have 3 routers and 1, 2, 3, 4 attached LANs for the routers. Okay, if you want to know more explanation, please go back to these lessons and you will find anything necessary to know about this topology. Okay, now before we explain the dynamic routing protocols, let us go back to the static routes. Static routes are excellent for routing to and from a stub network. Okay, what is a stub network? A stub network is an internal network that carries data packets only among local hosts. Data on this type of networks, a stub network, is destined to an endpoint located on that network. So the network traffic on a stub network is local, that it does not travel off the internal network. So for this type of networks, a stub network, the static routes are excellent. But there are disadvantages in using static routes. Okay, configuration and maintenance are time consuming. For the static routes, the configuration and maintenance are time consuming. And also configuration is error prone, especially in large networks. And it does not adapt dynamically to changes in the network. And as a result, it does not scale well. So these advantages in static routes should be solved, should be avoided. The dynamic routing protocols help provide the solution to the issues associated with the static routes. They are more scalable, they are easier to manage, they are they can actually determine the best path to remote networks and automatically adapt to changes in the network topology. So if you feel that the static route or static routing protocols do not serve your purpose in the topology, you should go to dynamic routing protocols, and you will get a solution for these issues. Okay, and sometimes you need to configure both static and dynamic routing protocols, and this is a special cases and you need for both of these two protocols, let's say for security reason, for maintenance reason, or if you want to let's say backup routing protocols. In case of one protocol fell down, you can use the other routing protocol. So sometime you need both of them configured in one topology. Okay, before we explain what is EGP, IGP and PGP, we have to know what is autonomous system, or AS. AS is a portion of a large internetwork that is under a given, let's say, administrative authority. Autonomous system can be under the authority of a particular corporation or institution. Here in this image we have three ASs, AS1, AS2 and AS3. These three ASs are connected to each other and under one administrative authority. Okay. The IGE, or the Interior Gateway Protocol, routing protocols are used for routing within an autonomous system. So inside each AS we have to configure at least one interior gateway protocol to get the routing protocols, routing the packet inside one AS. Okay, the exterior gateway protocols, or EGP, is used to route packets between AS. So we have here in this connection we have to configure one EGP, and here one EGP, and here one EGP. That is why we called this one interior and this one exterior. Okay. What about the border gateway protocol? Border gateway protocol is the current EGP used between autonomous systems on the internet. So on the internet, if you have two ASs communicate with each other, you will have one BGP to route the packet between these ASs. But this is done only on the internet. And sometimes in WAN you can find AS, but in general it is on the internet. And we have two versions, BGP 4, this is for IPv4, and BGP plus for the IPv6. Actually, this is beyond our lesson because this is the BGP, I mean, under the responsibility of the ISP. So we will only focus on the IGP, Interior Gateway Protocols. Okay, now there are four IPv6 Interior Gateway Protocols, which are, commonly used in the current networks. Number one, Routing Information Protocol, next generation, RIP-NG for short. Number two, Enhanced Interior Gateway Routing Protocol, EIGRP, and Open Shortest Path First version 3, OSPF v3, and the last one is Intermediate System to Intermediate System, IS-IS. These four protocols are famous and commonly used in the current organization networks. RIP-NG and EIGRP for IPv6 and OSPF v3 are separate processes from their IPv4 counterparts. So if you have dual stack, or you have both of IPv4 and IPv6 running in one network, and you want to configure one of these three IGP protocol, you will get separate process, for one for the IPv4 and one for the IPv6. ISIS support one process for both address families. Okay, but for the ISIS, we are not going to use it. We will only configure and explain actually the RIP-NG and EIGRP and OSPF v3. These IPv6 routing protocols are not much different than their IPv4 counterparts. The process and operations of the IPv6 routing protocols are basically the same as in IPv4. And we will do a comparison between the IPv4 protocol and IPv6 protocol in each IGP, and we will see that there is no much different in IPv4 and IPv6 protocols.